Okay, in the last lecture, we looked at some of the things which are related to the level of service determination. So we looked at the adjustment factors. Adjustment factors are required for free flow speed and capacity of freeways. Okay, for multi and highways, we don't have adjustment factors. So these adjustment factors can be because of weather, incident, work zone, and driver population. From these four, three have tables. So we look into the tables and you can find out the factor. Okay, but for work zone, we need to do some calculations. So we looked at the calculations, we did one example, and then we moved on to the calculation of free flow speed. Calculation of free flow speed is done when you did not or you cannot observe it. Okay, so calculation of free flow speed is not generally required. You can go in the field and find out that speed. Okay, because the spot speed study. Okay, so that gives you free flow speed. So in case you cannot do it, we looked at some equations, one for freeways, the other one for multi and highways, and there were some factors in those equations. Those factors included the factor for lane width, lateral clearance, ramp density, access point density, median type, and so on and so forth. Okay, moving on. What are the types of analysis which we can do using the level of service concept? So there are three types of analysis. First one, operational analysis. The second one, service flow rate and service volume analysis. And the third one, design analysis. In all these three analyses, we use the same basic equation in different forms. Okay, just keep this in mind. They are related to, or they are coming from the same source. Okay, which is the level of service. Okay, when I will show you the equations, they will look different, so I will not try to confuse you how I get equation number 2 from equation number 1, but just keep in mind that each of these analyses is using the same concepts and the same basic equation in different forms. Okay, so what do we do in operational analysis? This is important for your term projects. What you are doing in your term projects is operational analysis. So you have a highway, right? You have a segment. For that segment, you will find out level of service. Okay? This is operational analysis. Finding out level of service for a highway. This is called as what? Operational analysis. Second one is service flow rate and service volume. What does it mean? Service flow rate. I told you in the previous class as well as the lecture we had before that. We discussed about it twice. What is service flow rate? The maximum flow rate for a level of service. So finding out service flow rate and service volume for each level of service for your highway conditions is called as service flow rate and service volume analysis. So you have a highway. Now you are not trying to find out level of service. You are trying to find out at what flow rate level of service will be A, it will be B and C and so on. Got it? So for a highway, you are finding out what will be the service flow rate for each level of service and what will be the service volume for each level of service. Okay? And how do we convert flow rate to volume? By peak hour factor. Okay, the peak hour factor is a constant, right? If you know service flow rate, you know service volume. Then design analysis. In design analysis, you have somebody gave you volume and he's asking you to design a highway. So first of all, you tell him it's on your own risk. You are asking me to do the design. It's on your own risk. Huh? Right in the parking, right? Parking at owner's risk and so on. Okay. So when you become engineers, you should put this board outside your office. Huh? Work at your own risk. Okay. So in design analysis, they will give you the volume. Now obviously design means you design width and cross section, gradient and radius and so on and so forth. Here we are not talking about the entire design of the highway. We are talking about only number of lanes. Okay, so you already decided the other parameters, or you will decide about them, or you have assumed some values, but using level of service you will find out what number of lanes. Okay, so obviously design is for future. Okay, so the first two were for existing highways. In operational analysis you are trying to find out what? Level of service. In service flow rate analysis you are trying to find out what?
Like this level of service.
The service flow rate. Don't make it complicated. Service flow rate analysis you are trying to find out service flow rate.
Limit of level of service.
Yeah. You guys will not stop. Okay, fine. Maximum boundary. Very good. So in the exam I can give you these questions. Write down definition. Write an essay about service. We are fine with this, right? Deal? No? Deal or no deal?
No.
No? Okay. And in design analysis, number of lanes. Okay. Actually, even if you say yes, I will not give it because it's a torture for me. You write something in 5 minutes and go away. I have to spend like half an hour to read what is this. So, okay. So equation for operational analysis. Now keep in mind, in all these analyses, you need free flow speed. We already covered it. So everything we covered earlier, that is already required. You should have them. Okay, free flow speed, adjustment vectors, capacity, breakpoint, blah blah blah. Everything was required. Okay, so we are not talking about things which are different for each. Everything we talked about earlier, that was same. So when you reach to this stage, you have already done earlier analysis. Okay, so in operational analysis, we are trying to find out VP, which is the flow rate. Flow rate, existing flow rate of the highway, not service flow rate. Okay, how much is the current flow rate on the highway? Okay, so I need V, which is volume, and you can see peak hour factor. So V upon peak hour factor becomes flow rate. It's already volume divided by peak hour factor, it becomes flow rate. Then we have N, which is number of lanes. Number of lanes. Now keep one thing in mind, these analyses are done for each direction. So number of lanes, each direction. Okay, not total. Then we have FHV, which is called as the adjustment factor for heavy vehicles. Okay, so obviously your traffic will have some heavy vehicles, so we need to adjust them. So after you divide with all these things, your volume will be initially it will be in vehicles per hour. When you apply this equation, your VP will be in passenger cars per hour per lane. Okay, so capital V was vehicles per hour. VP is passenger cars per hour per day. Okay, clear? And we call it flow rate because we divide it with peak hour factor. So when you divide with FHV, it becomes passenger cars. When you divide by N, it becomes per lane. Okay. Then, so for calculation of service flow rate and service volume, we use this these equations. The first equation for calculating service flow rate, and flow rate multiplied by peak hour factor becomes volume. Okay, so how do we calculate service flow rate? So you can see N and FHV already explained, right? Okay, the only thing here to be explained is MSF, which is maximum service flow rate. Okay, maximum service flow rate. So you are putting maximum service flow rate, and the answer is what? Service flow rate. And some of you were saying service flow rate, maximum flow rate, same thing. Right? So what's the difference between this one and that one? Maximum service flow rate is under ideal conditions. Yeah, everything. Passenger car, whatever ideal conditions we have. Lane width and letter length, everything is ideal. Okay? So maximum service flow rate is under ideal conditions, and service flow rate is under existing conditions. Clear? Okay. How to find out maximum service flow rate? I explained in the previous class from the speed flow curve. You have to draw the curve, draw the diagonal lines. When the lines are intersecting the curve, that is your maximum service flow rate. Okay. So I will explain it again when we are doing the example. Okay. But keep in mind, maximum service flow rate is service flow rate under ideal conditions, and the other one, the one on the left hand side, is service flow rate, which is service flow rate in the existing conditions. Okay, and to find out maximum service flow rate, I have to draw the speed flow curve of the highway and draw the diagonal lines, which will give me the maximum service flow rate. Okay, so maximum service flow rate comes from the speed flow curve. Okay, and this is one more item which you have to do in your term projects. Okay, then this one I already explained. The equation for design analysis. In the design analysis, we are trying to find out what? Number of lanes. So N is number of lanes. Okay. Are we using anything different here? Nothing is different. All the terms which are written here, we already did. Right? So what is GTHP? Directional design hourly volume. Okay, but where did we do it?
During detail.
Yes, when you are discussing the peak hour factor in the same slides. Okay, so this is design volume, design hourly volume. Okay, because you are doing design analysis. Okay, and this must be for future. I already told you. Okay. Now in all these three equations, there are two factors which are common, all of them. Which are those? Which are what? Which factors are common in all these three equations? PHF, we know what is PHF, right? We discussed them, we calculated them, it came in the exam as well and so on. Okay, which other factor? Factor of heavy vehicles. Okay, did we discuss it earlier? She doesn't know.
No.
Now I mean earlier. Earlier doesn't mean now. No, okay. Okay, so, and the third thing was N and number of lanes. Simple. Okay, so FHV can be calculated using this equation. In this equation, you see two values are required. Okay, PHV, which is the percentage of heavy vehicles, and EHV, which is called as the passenger car equivalent for heavy vehicles. Okay, so PHV, percentage of heavy vehicles, EHV, passenger car equivalent of heavy vehicles. What is a heavy vehicle? According to this manual, any vehicle which operates on more than 4 tires is a heavy vehicle. Okay, now you may say my car has 5 tires, one is at the back, that doesn't count. Okay, the spare tire doesn't count. More than 4 tires on the ground. Okay, clear? So, and what is EHV? EHV gives you the effect of one heavy vehicle in comparison to a car. Okay, now heavy vehicle, which one is bigger, car or a heavy vehicle? A heavy vehicle is bigger, right? No? In most of the cases. Some of us have big cars. Okay, good for you. Get out of my class. But, you know, mainly heavy vehicles are bigger, so they take more space. So the space taken by one heavy vehicle could be the same space in which you may fit more than one car, right? And what else? Heavy vehicles are also, when it comes to speed, heavy vehicles are slower. Okay, so because they are taking more space and they are moving slowly, so having one vehicle in traffic flow is like having 2 or 3 cars. The effect of one heavy vehicle in terms of space and speed will be same as 2 or 3 cars. Okay, I'm just giving examples. 2 or 3 cars is just an example. The factor is not constant. Okay, so that is the effect which we call as EHV, passenger car equivalent. So one heavy vehicle is equal to how many passenger cars in terms of traffic flow? Clear? Any questions? Okay. Will the heavy vehicle have the same effect on a level ground and a slope? No. So that means EHV cannot be same for different ground conditions, right? And ground conditions change, EHV has to change. Okay. The ground conditions are mainly divided, ground or terrain. So they can be mainly divided into 2 categories: general terrain and extended gradient. General terrain and extended gradient. General terrain have further 2 subtypes: level, rolling. So general terrain can be level or rolling, and gradient can be what? Gradient can be what? Upward or downward, right? Understood? So there are 2 main terrain conditions: general terrain, extended gradient. General terrain has 2 subtypes: level, rolling. Okay, and gradient can be upward or downward. Okay, now how do I know that I have a general terrain or extended gradient? Okay, so for that they have given me 2 criteria. If I meet any one of them, I have extended gradient. If I meet any one of these criteria, then I have extended gradient. If I don't meet any of them, then I have level or rolling, general terrain. Okay, what are these 2 criteria? These criteria depend upon the gradient. If the gradient is more than 3%, then for general terrain, its length should not be more than 0.25 miles. Gradient more than 3%, length up to 0.25 miles maximum. If you meet this criteria, general terrain. Okay, so gradient more than 3%, length 0.25 miles or less, that is general terrain. Okay, if the gradient is less than 3%, then the length should not be more than 0.5 miles. Gradient less than 3%, length should not be more than 0.5 miles. Then it is general terrain. Okay. So for example, I have a gradient of 4% and length of 1 mile. Is it general or extended gradient? Extended. Gradient more than 3%, right? So length should not be more than 0.25 miles. So 1 mile means it is extended gradient. Got it? If I have 2% gradient and 0.2 miles length, what is it? General terrain. Okay, for gradient less than 3%, the length can go up to 0.5 miles. Okay, so if I have 2% gradient, the length is 0.2 miles, general terrain, 0.3 miles, general terrain, 0.4 miles, general terrain, 0.5 miles still general terrain. When it goes more than 0.5 miles, now it's extended gradient. Got it? Clear? Okay. Now once you know that it is general terrain, then you know we have level and rolling. Less than 2% gradient in general terrain is level. More than 2% is rolling. Got it? Okay. We are not talking about length here because length we already checked. We checked the length, right? So that's why we are now checking for level or rolling. So level or rolling only depends upon gradient. That's it. Okay. So you already know it is general terrain. Now just look at the gradient. That's it. Clear?
So and first we check the gradient also.
We are not checking the gradient. We are checking the length for the gradient. Gradient can be less than 3%. Gradient can be more than 3%. Less than 3%, what is the length? 0.5 miles. So we are checking for length. If it was more than 3%, I will check for length to be 0.25 miles. So I am checking for length. Once you have checked for length and you know it is general terrain, now I will check for gradient to know which type of general terrain. Okay, and this table gives you the EHV factor for each general terrain type. Got it? Any other question? Clear? These are the tables. We have lots of tables for gradients, extended gradients. Okay, so you need to put the value of the gradient in the first column, the length of the gradient in the second column, and the percentage of heavy vehicles in the top row. You cannot see it here, but it's there, right? The top row. So you need three things to find out the EHV factor when we have extended grade. You should know the value of gradient, you should know the length of gradient, and you should know the percentage of heavy vehicles. Clear? Okay. So these are the factors. So we said gradient can be upward and downward, right? This table is for what? Upward and down or downward? It's upward. Upward. Okay. Can I use it for downward? No. Yes. Can I use it for downward or not? Sure. Sure. This is the only table I have.
Change the sign.
Huh?
Change the sign.
Very good. People spend years in making this table, you change the sign. Very good.
But it's slower.
Huh?
Heavy vehicles are slower upwards.
My question was not heavy vehicles are slower or down for upward or downward. My question is, can I use this table for downward or not? You said no. Everybody said no, right? So everybody is wrong. Okay. The first row. Look at the first column, first row.
2%.
Huh?
2. First row is 0.
Okay. Got it? Got it? Okay. Okay. Now you see, I don't have different tables for upward and downward, but I still have two tables. Two tables. Okay, so the purpose of asking you this question, that whether I can use a table for downward or not, is to clear in your mind that you can use the same table for upward and downward both. Okay, so those two tables are not for, one is for upward, the other one is for downward. It's not like this. Okay, it is for different mix of heavy vehicles. Okay, the first table, there's the first one or second one? There's the second one. Okay, so this is for a different mix of heavy vehicles, and this one is for a different mix of heavy vehicles. Okay, how did you define heavy vehicles? Any vehicle which has what?
Or equal 6 ton.
Very good.
More than 4 times.
More than 4 tires, right? Okay. Now if you look at a small bus or a big bus, okay, both of them are buses, right? So you call them, both of them, as heavy vehicles. Okay. And if you look at those big trailers which bring the, what do they call them, containers from the port, have you seen them? Okay, they are very long trucks. Okay, and if you have seen the trucks or the trailers in which the cars come, they are very, very long, 16 wheelers, 30 wheelers. Okay, so they are trucks which are heavy vehicles, and buses which are heavy vehicles, and then there are these long trailers. They are also heavy vehicles. Okay, but that one is called as simple trucks, okay, or single unit truck. Okay, the first one, the buses and the small trucks, we call them single unit trucks, SUT, single unit trucks. Okay, and those big trailers which carry containers and cars and these things, we call them trailer trucks. Okay, so a single unit truck has a single body, you can see it from, like your car, a single body. But a trailer truck, when you remove the container from it, you will see the back of the truck is just a platform, that's it. There is no body. Behind the truck there is no body. It's just a long platform, that's it. Load anything. Okay, so that's the main difference between a single unit truck and a trailer truck. A single unit truck has a monolithic body. It's one body. Okay, but a trailer truck has a front side, okay, where the driver is sitting, and behind that is just an empty space. That's it. You can load trucks, you can load cars, you can load bikes, whatever. Okay, and they are longer. I told you, 16 wheelers, 30 wheelers. Okay, so they are big trucks. Okay, usually single unit trucks are more, trailer trucks are less. Okay, so in that case you will use this table. So this table where they did not mention the mix of heavy vehicles, we call it the default mix. Okay, so the default mix or the standard mix is 70% single unit trucks and 30% trailer trucks, and in that case you will use this table. Okay, if both of them are equal, 50% trailer trucks, 50% single unit trucks, okay, then you will use that side of the table. So I'm talking about the second table. This is the second table now. Okay, so on the right hand side of the table are the values for 50% trailer trucks, 50% single unit trucks. Okay, and on the left hand side, these columns, okay, they are for 70% trailer trucks and 30% single unit trucks. Okay, so there are three possibilities, right? Single unit trucks are more, you go to the first table. If single unit and trailer truck are equal, you come to this table on the right hand side. If trailer trucks are more, single unit truck is less, you come to the left hand side. Got it? So two tables for three conditions. Clear? Any questions? Okay, so I told you the first table is the standard default. More trailer trucks, less single unit trucks. Now when I say 70% single unit trucks and 30% trailer trucks. The total is how much? 100%, right? Where are the cars? All trucks? Where are the cars?
Because here we calculate only for heavy vehicle.
Hmm.
We are talking about percent heavy vehicles.
Yes.
So this is 30 and 70 from the heavy vehicles. So if I say my traffic has 10% trucks. So when I say 30% single unit and 70% trailer trucks, this is 30 and 70 of that 10%, not the whole traffic. Okay, there is no road on the world which has only trucks. Okay, so the mix is from the percentage of heavy vehicles. It's not for the entire traffic. Okay, the mix which I am showing you, 70% this, 30% this, is 70 and 30 of the heavy vehicles. The cars are there. Got it or not? Clear? Okay. I'll try to explain more when we are doing some numerical examples. Okay. A freeway operating in general loading terrain has a traffic composition 12% trucks, 3% RVs. RVs means recreational vehicles. In the old manual, they were treating them separately, but now they are equal, so no problem. Okay, so RVs are heavy vehicles. That's it. Recreational vehicles are heavy vehicles. You don't have to worry about them, what they are. So trucks are heavy vehicles and RVs are heavy vehicles. So total heavy vehicles, how many? 15%. So when I say 70% single unit trucks and 30% trailer trucks, it is 70 and 30 of this 15%. Okay, clear? 70 and 30 of 15%. The remaining 85% are cars, we know that. From the 15%, 70% are this and 30% are this. Got it? Okay. So we want to, we have observed volume 3,200 vehicles. Out of 3,200, 15% are trucks and RVs and the remaining are cars. We want to convert this volume into passenger cars per hour. Okay, from vehicles per hour to passenger cars per hour. Okay, there is it's rolling terrain. So they already looked at the gradient and the length, they already decided it is general terrain, and from general terrain it is rolling. Okay, so we will just focus on the conversion. We don't have to worry about the terrain conditions. So it's rolling terrain. We can convert vehicles to passenger cars in two ways. There are two methods to do it. First method is using the equivalency factor directly, EHV value directly. Okay, for rolling terrain, how much is the EHV value? 3. Okay, this one. Okay. Okay, so I know EHV factor is 3. Okay. So I will apply this EHV factor to what percentage of vehicles? Heavy vehicles, right? Heavy vehicles are how many? 15%. Now 15% means what number? Give me a number for 15%. So total is 3,200 and heavy vehicles are 15%. So how much is it? Okay, so 15% of 3,200 is how much? 480. These are now heavy vehicles, right? Okay, and we said that each heavy vehicle has a equivalency factor of how much? 3. Okay, so in order to convert these heavy vehicles to passenger cars, I'll multiply this number with the equivalency factor. So how much will it be? 1440. Now this becomes what? Passenger cars. After multiplying with the equivalency factor, they become what? Passenger cars. Okay, then how many are passenger cars already? What is the number of passenger cars already? Which is 85% of 3,200, right? So what is this? 2720. See, these are already passenger cars, right? So 2720 were already passenger cars. 480 were heavy vehicles. I converted them to passenger cars. So what is the equivalent total now? For so you added 1440 and 2720, right? Okay, so you see 3,200 converted to passenger cars. They applied the factor directly to the percentage of vehicles which were heavy vehicles. This is one way of doing it. The other way is use the heavy vehicle factor. Okay, the FHV. Use this equation. Okay, so here okay, so this is my equation. So what will be my FHV here? Percentage of vehicles 3%. So we'll put 0.03, okay? Oh sorry, 15%, 15%. So you will put 0.15, okay? And EHV is 3. EHV will not change. Okay. So how do I use FHV to convert vehicles to passenger cars? I divide the volume with FHV, simple. So now the equivalent total will be 1,200 divided by 0.76. Okay, it should be same, right? Both methods should give you the same answer. So these are the two methods by which you can convert the vehicles to passenger cars, but obviously we already have in our equations FHV divided. Okay, so the equations are using this method, all of them. All of the equations are using this method, so you will be using this method, but the first method can also be used. There's no problem with that. Okay, any questions? Clear? Okay. Another problem which we can have is, for example, you are doing a long segment. In that long segment, the gradient may be changing. The road gradients are not constant over long lengths for one reason or the other. We don't keep the gradient constant, keeps on changing. Okay, so what do we do in that case? Because if I go to the table, if I use this table, I need one value here, right? Okay, but if I have, for example, like they have given 3 values, see? There are 3 values here. Okay, 3%, sorry, 2 values, 3% and 5%. So what should I do in that case? We can calculate an average. Okay, We can do the analysis for each one of them separately, but it will take long time. Huh? But we have lots of time, we can do this, right? Okay. We will take an average. We'll say over time we'll take an average. But how to take the average? 3 plus 5? Weighted average. Weighted over what? The length. Okay. They call it, it's weighted average, yes. They call it the average gradient method. What is the average gradient method? So according to average gradient method, they take sum of difference in heights divided by sum of length. So we have two gradients, right? For each gradient, I will calculate the difference in height. And for each gradient, they have given me the length. So difference in height will go on the top and the length will go at the bottom. Okay. For example, okay, so the first gradient 3%, right? And the length is 3000 feet. So what will be the difference in height for this gradient? The gradient into length will give you difference in height, right? Okay. Same for the other one. Okay, this is for 3% gradient. Yeah, it's big enough. And this is for 5% gradient. Okay, clear or not? Divide by sum of length. So 3000 plus 5000. So how much is it? 0.042. Okay, so basically 4.2%, right? Clear? So yes, they are taking the weighted average, or weighted average according to the length. They multiply with the length, right? But because it looks like slope, total height upon total length, so they call it average gradient. Clear? Any questions? Okay, there are some more examples given. You can try them. Okay, so you when you go to the table, for example, in this case, when I go to the table, I'll look for 4.2% gradient, which is not here, so I will do interpolation, obviously. And I will look for length, total length now. So one gradient has 3000, the other one has 5000. Total is 8000. And then you have to convert 8000 to miles because this is in miles. Clear? So if I need EHV factor and somebody gives me multiple gradients, I'll convert those multiple values into average and use that average for EHV. Clear? There are some examples that I told you, and you can see in this example they are using 3. So you will calculate 3 differences of heights upon 3 lengths. Clear? Any questions? Now usually it doesn't happen that some gradients in the same direction, that some gradients are going upward and others are going downward, because it will create a problem with the flow of water, drainage. So usually it doesn't happen. But if it does happen, then what do we do? For example, if one of them was downward, what do we do? As negative, simple. Downward is negative. Okay, but usually it doesn't happen that I'm going in the same direction. Okay, one gradient is downward, the other one is upward, then I have downward again, because you see what will happen, it will be like this. Okay, so usually it doesn't happen except on the curves, vertical curves. Okay. Okay, we will do it tomorrow, inshallah. So tomorrow we will have regular classes, huh? Both.